How'd you go? Were you able to help the monsters? Were you able to help them so that they didn't bump into each other? Did you find any lines that didn't cross? Most pairs of lines kind of cross, huh? But if you're really careful, you can find lines that don't cross. We call them parallel, and they go on forever and ever and ever. But if you kind of get down low and you look out, it sort of looks like they cross. Way, way, way out at infinity. So here's the horizon. There's a beautiful little sun going on there. And here's some train tracks that go off to the horizon. What would the other side of this train track look like? What does it look like is going to happen? Does it look like they're going to intersect or not?
Yes.
It does look like they're going to intersect, right? I mean, you'd have to. How far would you have to go to get to the point where they intersect?
A lot of miles.
A lot of miles.
Oh, wait.
The other side.
Look like that.
It would look something like that, right?
Oh, because it would be like...
Now, mathematicians love it when they don't have to keep track of exceptions. So if we could somehow redefine lines so that we include that point out at infinity, then every pair of lines would have exactly one intersection point. So that's exactly what we do. If we redefine a line to be all the points on the line plus one extra point that corresponds to the slope of the line, then any two lines either cross or they're parallel. But if they're parallel, they've got the same slope, and so they cross way out at infinity. Now, every pair of lines cross exactly once. Pretty nifty. All right, nobody has a piece of paper big enough that goes all the way out to infinity. So how about we take a leaf out of the world of video games? Actually, the world of video games took a leaf out of the world of mathematicians, but who's counting? It comes back in the bottom, and then it goes out the side, and it comes back in this side.
Like,
And if we keep doing this, like a little Pac-Man type thing or something like that. I think Pac-Man did this.
Yeah.
Let's have a line that goes out in this direction. And if we do that, it comes back in this side. But then it goes out here and comes back in over here. And out here and comes back in over here. And out here and back in over here. And it kind of just keeps doing that. Well, that's pretty nifty. But if you're like me, you get a bit distracted and you start wondering about these lines that go boom, boom, boom. And if indeed they'll ever come back to the same spot, because it was all very nifty when we went backwards and forwards there. But what if we went chuffing off out there and went skadoodling up? Oh, but we went out the side, so we come back in there and go skadoodling up. Now we've gone out the top again, come back down there and we go skadoodling up. Bouncing all over the place. Would it ever come back to itself? Lines that start in the bottom left corner, they look like y equals mx. The b is 0. We don't even need to worry about that. So what happens if we let the slope vary? How many times do you think it's going to go out the top before it comes back to the bottom? Obviously it's going to depend on the slope of this whole thing. Why don't you ever play around with that? See if you can see what's going on.